branch of science dedicated to explain the hidden structures of our universe serve as the basis for various scientific fields, such as material science, pharmacology, as well as chemical engineering.
Chemistry teaching relies heavily on visual aids to explain its concepts, from Lewis structures to the periodic table of elements. Now imagine trying to learn chemical structures without being able to see a single molecule. The most common chemistry tool used in the classroom, the ball and stick model of chemistry structure, is completely indistinguishable by touch, difficult to put together, and even more difficult to pull apart, leading to an infuriating and even useless experience for the visually impaired. Furthermore, existing tactile tools are rare, expensive, and lack interactivity.
Therefore, Bonded aims to create an inclusive, interactive, and affordable chemistry learning tool for all students, including those with visual impairments, for them to understand atomic and molecular structure through touch, allowing inclusivity and promoting equal learning opportunities.
Bonded was developed following the design thinking process. After identifying the problem, our team designed tactile atoms with unique textures, circles for oxygen, dots for hydrogen, and bumps for nitrogen, to make each distinguishable by touch. The atoms are magnetized to simulate bonding and accurately reflect molecular geometry, such as water's V shape or methane's tetrahedral form. The components were 3D printed using recycled plastic filaments to ensure sustainability and low production costs. After several prototype refinements, we tested the product with students, both blindfolded and sighted, to evaluate usability and accuracy in forming molecules. Overall, the feedback was positive, and the blindfolded testers were able to create molecules such as H2O and ethene with minimal instruction.
Bonded is a tactile molecular model designed to make chemistry accessible for visually impaired students. It uses 3D printed atoms made from biodegradable PLA plastic, each with distinct textures so different atoms can be identified through touch. Embedded magnets simulate chemical bonding, allowing students to connect atoms and build molecules such as water. This hands-on approach turns abstract chemical concepts into tangible learning experience. Bonded also supports inclusive classrooms, enabling visually impaired and sighted students to learn chemistry together.
Now, it's time to talk about how Bonded can change the way we teach chemistry today. Firstly, it opens the door for visually impaired students to learn about molecular structures in all its complexities, covering aspects such as molecular geometry and types of bonding. This, in turn, promotes inclusivity in STEM learning to ensure that everyone gets an equal opportunity to receive quality education. In fact, as students can get an actual feel of the different atoms and molecular structures, they will naturally gain a deeper understanding of the concepts. Plus, the fun nature of this product offers students a fun, enjoyable experience while learning. Thus, it can encourage students to carry out hands-on learning, which has been statistically proven to ease the learning curve for students. Last but not least, our 3D printed models use affordable and durable PLA filament, which helps us reduce production cost. Moreover, since each kit can be used in multiple classes, it is highly suitable for school use. In addition, all materials can be sourced locally, allowing us to save money on potential import fees. Furthermore, with the flexibility of 3D printing, we can easily update or produce models in bulk without needing costly molds, saving both time and money.
In a nutshell, this project is aligned with SDG 4, Quality Education, which advocates for inclusive education. As we all know, knowledge knows no bounds, and Bonded advocates for a world where all people is able to access a world of knowledge without restrictions. So, consider Bonded, where discovery is waiting in every hand.